Assalamualaikum and hi, my name is Binti Aidell with the metric number of 73282. I am from PKE 1. In today's video, it will be about our mini project, which is how to measure using multimeter. In this project, we will be using this circuit diagram which is given. It consists of 3 resistors, which is R1, R2, and R3, and also a power supply of 1.5 volt. As you can see, R2 and R3 are connected in parallel while R1 is connected in series with R2 and R3. So by using nodal analysis, so I label this one as node VA. So after that, we apply KCL, and we know that current going in, the sum of current going in is equal to the sum of current going out. So we label I1 going in and I2 and I3 going out. So I1 is equals to I2 plus I3. Put the value in and we get VA is equals to 0.5 volt. To find voltage across each resistor, I will use the value of VA that we get before this. So 1.5 minus by 0.5. So V1 here would be 1 volt, and for V2 and V3, the voltage should be equal because they are connected in parallel. So, and they are also equals to VA, which is 0.5. So V2 is equals to VA, which is 0.5 volt, and the same goes to V3 because V2 is equals to V3. And to find current through each resistor, by using Ohm's law, I is equals to V over R. So I just substitute all the value and the value given, and I1 is equals to 1 milliampere, I2 is equals to 0.5 milliampere, and I3 is equals to 0.5 milliampere. First, we need to check the measured values of these 3 1 kilo ohm resistor. So set your multimeter to ohm. Okay, so R1 0.956 kilo ohm, and then R2 0.962, and then for R3 0.958. So we're gonna start building our circuit based on the schematic diagram given. So 1.5 volt, and then R1 is in series, and these two will be in parallel. So we start off by the power supply, positive, positive, and then negative, positive, negative. So I'm gonna start by putting the resistor. The first R1 is in series. I'm gonna put it horizontally. Okay, it's horizontal, and then you can see that it shares the same node here. So I'm gonna put R2 in the same line, same column as the R1. Okay, it's in the same column. It's done, so it might look different, but yeah. And then R3 is in parallel, so put it in parallel. No problem with this. Okay, so we're not done yet. We have to connect it by using wires. So I think we start off by this one. this with this, and then this two. And then this two, because it's in parallel, right? Oh. Okay. And then this one would be here in the line of R2. Yeah. Put both supply together. And I think that's it. So it follows the schematic where the power supply and then R1 and then share the same node, and then R2, and then it's in parallel with R3. Connect the wires, and then to the power supply. Yeah. First of all, we measure the total voltage by checking the power supply. 1.65 volt. So the total voltage is 1.65 volt. To find total current, so I change the setting, so I make it into 20 amp, and then I'll take these two off, and hold on. And check the current. 1.12. So we will be measuring the partial voltage. So first is for the series one, which is R1, 1.09. The second one, 0.54. And the third one, 0.55. So we will start measuring the partial current. So first we're gonna look for I1. So this is the first one. So I'm gonna take this off, disconnect this, and also this one. So it's 1.11. As for I2, to find I2, you gotta disconnect the R2 and then take another connecting wire and put it there on the place you disconnected, and measure. Zero 0.56. Repeat the same step to measure I3. So you disconnect resistor number 3, put a connecting wire, and then measure. This is I3. So as you can see, it's 0.55. So these are the values that I have recorded for measured, calculated. Is the one that we calculated at first, And then this is the result that we get when measured using the multimeter. So partial current, partial voltage, total current, total voltage. So first, it shows a slight difference, but not that far, I guess. So first would be total voltage. We are supposed to use a 1.5 volt battery, 1.5 volt, but when checking with the multimeter, when using the multimeter, it shows definitely more than that. It shows 1.64, which I recorded 1.65. So that might be the main reason why it's not, the measured and calculated is not the same. So, and the next reason would also be the resistance value. It is supposed to be all 1 kilo ohm, but measured using multimeter, we get 0.956 kilo ohm, 0.962, and 0.958. But it's okay because the difference is not that big. So when measuring the total current, it's supposed to be 1 when calculated, but we got 1.12, 0.12 difference. At partial current, when measured from the test point, A to B, D, E, and GH, which is I1. I said in the video, this one, I refer to this as I1, I2, and I3. So we measured 1.11, 0.56, and 0.55. Well, it is calculated as 1 milliampere, 0.5 milliampere, and 0.50. As for partial voltage, we calculated at BC, it's supposed to be 1 volt. EF, it's supposed to be 0.50, and HI is supposed to be 0.50 also. But we got 1.09 volt for BC, 0.54 volt for EF, and 0.55 for HI.